The reason German engines from manufacturers like Mercedes, BMW, and Porsche routinely exceed 500,000 miles isn't exotic materials or secret technology. It's a combination of conservative design principles including adequate cooling systems, proper bearing clearances, quality filtration, and most importantly, religious adherence to scheduled maintenance with high-quality fluids that American drivers often skip to save money. According to automotive longevity research and high-mileage vehicle analysis, engines reaching extreme mileage share specific characteristics. They run cooler through oversized cooling systems, use full-flow oil filtration with quality filters changed frequently, maintain precise bearing clearances through proper oil viscosity and regular oil changes, and avoid operating conditions that create excessive stress like constant high RPM or repeated cold starts without proper warm-up. Independent studies of taxi fleets, delivery vehicles, and private high-mileage examples show that properly maintained German engines, particularly older naturally aspirated diesels and inline-six gasoline engines, can exceed 1 million kilometers, or 600,000 miles, with only routine maintenance and no major overhauls. The key insight is that German manufacturers design their engines with significant safety margins and conservative stress levels, meaning components operate well below their failure threshold during normal use. Compare this to some manufacturers who design engines to barely meet expected service life to reduce costs. Keep watching, because I'm going to explain the specific engineering principles that enable extreme longevity, show you how to apply German maintenance philosophy to any engine regardless of manufacturer, reveal which specific practices make the biggest difference, and calculate whether the higher maintenance costs are worth the extended engine life. Hey, if you like this kind of straight-to-the-point content with no BS, help me out here. Subscribe to the channel right now. It takes 2 seconds and guarantees you won't miss any tips that could save you some serious cash. Let me start by explaining the core engineering principles German manufacturers use that differ from other approaches. First principle is thermal management through oversized cooling systems. German engines, especially from BMW, Mercedes, and Porsche, typically have larger radiators, bigger coolant capacity, and more robust water pumps than competing engines of similar power output. The philosophy is that lower operating temperatures reduce thermal stress on all components. Oil stays more effective at lower temperatures. Gaskets and seals last longer. Pistons, rings, and cylinder walls experience less thermal expansion and contraction cycling. Testing shows that every 10 degrees Celsius reduction in operating temperature approximately doubles component life. German engines often run at 185 to 195 degrees Fahrenheit, compared to 205 to 220 in some American engines. This conservative temperature management costs slightly more in parts and reduces maximum power potential, but dramatically extends service life. Second principle is proper bearing design and clearances. Engine bearings are the critical wear items that ultimately determine engine lifespan. German engineers specify bearing materials, surface treatments, and clearances very conservatively. They use quality bearing materials like aluminum tin alloy or copper lead with protective overlays. They maintain precise clearances that provide adequate oil film thickness, even as wear occurs. They design oil passages to ensure all bearings receive sufficient flow at all operating conditions. In contrast, some manufacturers use tighter clearances or minimal oil passages to reduce friction and improve fuel economy, but this reduces safety margins and accelerates wear under stress. Third principle is comprehensive filtration. German engines typically use full-flow oil filtration with high-quality filters that remove smaller particles. Many use additional filtering, like magnetic drain plugs or secondary bypass filters. The philosophy is that any contamination that enters the oil should be captured before circulating through bearings. Higher quality filtration costs more, but extends oil and bearing life significantly. Fourth principle is forced induction with conservative boost levels. When German manufacturers use turbochargers, they typically run lower boost pressures than competitors making similar power. For example, a German turbocharged engine might run 12 psi boost, where a competitor runs 18 psi to achieve the same output from a smaller displacement. The lower boost means lower thermal and mechanical stress, increasing longevity even though it requires a larger engine. Fifth principle is quality over cost cutting. German manufacturers historically used better materials, more precise manufacturing tolerances, and higher grade fasteners and gaskets. This increases initial cost, but reduces failure rates and extends service life. Recent German engines have moved toward cost-cutting, unfortunately, which is why many enthusiasts prefer older German engines from the 1990s and 2000s over newer designs. Now let me explain how German maintenance philosophy differs from typical American practices and why this matters for longevity. German manufacturers specify very strict maintenance schedules with short intervals using high-quality fluids. The typical German maintenance approach includes oil changes every 7,500 to 10,000 miles, using full synthetic oil meeting specific manufacturer specifications. This seems standard, but the key is using the correct oil specification, not just any synthetic. Mercedes-Benz, BMW, and other German brands have detailed oil specifications like BMW LL01 or Mercedes MB2229, 5 that require specific additive packages and base oil quality. Using generic synthetic that doesn't meet specifications can cause problems. Transmission fluid changes are specified at regular intervals, typically 30,000 to 60,000 miles for automatic transmissions. Many American drivers ignore this, believing transmission fluid is lifetime. But German engineers specify changes because fresh fluid extends transmission life dramatically. Coolant, system service every 2 years, regardless of mileage. This seems excessive, but coolant degrades over time even without mileage, losing corrosion inhibitors and pH stability. Old coolant causes internal corrosion that ruins radiators, water pumps, and heater cores. Spark plug replacement on gasoline engines every 30,000 to 60,000 miles, depending on type. German engines often use premium plugs costing $20 to $40 each rather than cheap plugs, and they specify shorter intervals because slightly worn plugs increase combustion chamber deposits. Air filter and fuel filter changes at manufacturer-specified intervals, which are often shorter than American standards. Clogged filters reduce performance and increase wear. Valve adjustment on engines with mechanical valve adjustment every 60,000 miles or as specified. Proper valve clearance reduces valve train wear and prevents valve damage. The German philosophy is preventive rather than reactive maintenance. Service components before they fail rather than waiting for problems. This costs more in routine maintenance, but dramatically reduces major repairs. Studies of high mileage German engines show that those following factory maintenance schedules have failure rates less than 10% of those with deferred or minimal maintenance. Now let me explain how to apply these principles to any engine to maximize longevity. You don't need a German engine to achieve high mileage if you follow German engineering principles. First, use the highest quality oil that meets or exceeds your manufacturer's specifications. For most engines, this means full synthetic oil changed at manufacturer intervals, or more frequently, if you do severe service driving. Oil analysis can determine optimal intervals. Use quality oil filters from reputable manufacturers, not the cheapest available. Second, maintain the cooling system religiously. Change coolant every 2 years. Inspect hoses and replace any showing deterioration. Ensure the radiator is clean and airflow isn't blocked. Replace the thermostat at manufacturer intervals even if it seems to work, because failing thermostats can cause overheating. Verify the cooling fan operates properly. Cooling system neglect causes more engine failures than any other factor. Third, change transmission fluid regularly regardless of manufacturer claims about lifetime fluid. 30,000 to 60,000 mile intervals are ideal. Fresh transmission fluid prevents clutch wear and keeps internal components clean. Fourth, avoid operating conditions that stress the engine. Let the engine warm up at idle for 30 to 60 seconds before driving. Then drive gently until fully warm. Avoid constant high RPM operation or full throttle. Acceleration until warm. Minimize short trip driving, where the engine never reaches full operating temperature. These practices reduce thermal cycling stress and prevent oil contamination. Fifth, use quality replacement parts when repairs are needed. Aftermarket parts vary wildly in quality. German OEM parts, or quality aftermarket equivalents, from brands like Bosch, Continental, or Mahle, cost more but fit properly and last longer. Cheap parts from unknown manufacturers often fail prematurely, creating cascading problems. Sixth, address problems immediately before they become catastrophic. A small oil leak, unusual noise, or minor coolant seepage that's ignored becomes an engine-destroying failure. Fix problems while they're small and cheap. Seventh, keep detailed maintenance records showing all service performed with dates and mileage. This documentation increases resale value and helps you track service intervals. The cost analysis of high maintenance versus cheap maintenance shows significant long-term savings. Consider a vehicle kept 15 years or 200,000 miles. Cheap maintenance approach, oil changes every 10,000 miles with conventional oil at $30 each, equals 20 oil changes for $600. Skip transmission service, defer other maintenance until problems occur. Total routine maintenance, approximately $2,000. But engine or transmission failure at 150,000 miles requires replacement costing $5,000 to $10,000. German maintenance approach, oil changes every 5,000 miles with synthetic at $70 each, equals 40 oil changes for $2,800. 3 transmission services at $250 each equals $750. Coolant services, filters, and other preventive maintenance adds $1,500. Total routine maintenance approximately $6,000, but no major failures occur. Engine and transmission last vehicle lifetime. Net savings, cheap maintenance costs $8,000 to $12,000 total with major repairs. German maintenance costs $6,000 with no major repairs. The German approach actually saves $2,000 to $6,000 over the vehicle life while providing better reliability. Beyond financial benefits, proper maintenance provides peace of mind, better resale value, and the satisfaction of taking care of your equipment properly. So here's the bottom line. German engines last 500,000 miles or more because they're engineered with conservative design principles, including oversized cooling systems, proper bearing clearances, quality filtration, and adequate safety margins in all components. The equally important factor is strict adherence to maintenance schedules using high-quality fluids and parts. You can apply these same principles to any engine, regardless of manufacturer, by using quality synthetic oil with frequent changes, maintaining the cooling system religiously, changing transmission fluid regularly, avoiding stress conditions, using quality parts, and addressing problems immediately. The German maintenance approach costs more in routine service, but prevents catastrophic failures, actually saving money long-term while extending engine life dramatically. The choice is yours. Save a few $100s on maintenance and spend thousands on repairs, or invest in proper maintenance and drive the same engine for decades.